Assalamualaikum and good day everyone. Before we start, I would like to share a little bit about us. We are students from Postgraduate Diploma in Education in Unitar. We are conducting our MicroTeaching assignment for our teaching methodology subject today. So today we are going to have 4 teachers with us, which are Teacher Tasha, Teacher Humaira, Teacher Sumaiyah, and me, Teacher Ain. I would like to thank everyone for joining our class today. Before we begin, I would like to remind all of you to off your mic and open your camera for recording purposes. So, before we begin, I would like to invite all of you to open your camera for photo session. I will pass to Teacher Humaira to count the photo session.
Okay. 1, 2, 3. One more time. 1, 2, 3. Okay.
Okay. Thank you, Teacher Humaira. So, in count of 3, we are going to start our class as per schedule. 1, 2, and 3. Hello and good morning, class.
Good morning, teacher.
Good morning, teacher.
Good morning,
teacher.
Morning. Have you all had your breakfast today? I hope everyone has eaten, so you have enough energy to learn. Alright, today we are going to continue our topic on light. Do you know that light can be refracted? So let us explore what that means. Have you ever noticed when you drop a coin in water, it looks like it's a different position, almost as if it's higher or lower than it really is? That is because of refraction. Refraction happens when light bends as it travels from one medium to another, like from air to water. This bending occurs because light changes speed when it enters a different materials. This property helps us in many ways. For example, refraction is used to make camera lens, contact lens, microscope, and telescope.
Excuse me, teacher. How do microscopes use refraction?
Excellent question, Tasha. Your curiosity is very high. After this, teacher will show you the slide about microscope and telescope to answer your question. A microscope uses convex lens that refract light from the specimen. The bending of light makes the image appear larger and clearer.
Teacher, how about telescope, teacher?
Great question. You are so fast. For this, I would like Teacher Humaira explain that to you.
Okay. Thank you, Teacher Ain. So, a telescope also uses refraction. It has 2 main lenses, the objective lens and the eyepiece lens. The objective lens gathers light and the eyepiece magnifies it, allowing us to see distant objects clearly. Another beautiful example of refraction is a rainbow. When sunlight enters raindrops, it slows down, bends, and splits into different colors. That's how we see the spectrum of colors after rain. Gentle reminder for everyone, please keep your mic off unless you're asking a question. Raise your hand first, okay?
Sorry, teacher.
It's alright. Let's continue. Now let's watch a short video to help you visualize how refraction works.
Teacher, I can't hear the volume of the video.
Sorry. I will share to you again.
Thank you, teacher.
Welcome.
If you look from above at a pencil that's partially submerged in water, you see that the part that's underwater looks kind of bent or misshapen. Remember that you see any object because light waves are coming off that object and reaching your eye. But those light waves behave differently in different materials. They travel faster or slower depending on the material. Light travels faster through air than it does through water or plastic. So when light travelling through air reaches a plastic block, for example, it slows down. To understand why the pen looks weird through water, let's forget about light for a second and picture a car travelling along a road surface, then reaching a patch of sand. Just like the light wave, the car slows down as it reaches a different material. But now imagine the car reaches the sand at an angle. As the first wheel reaches the sand, it slows down. But for a short period of time, the other wheels continue at a faster speed. Because the wheel on one side is going slower, the whole car turns slightly. Once the whole car is on the sand, it continues in a straight line, but not the same straight line that it was travelling on along the road. Light rays work in the same way. If light rays are moving through air and reach a different material at an angle, they'll change direction slightly. This is a ray box that we often use for light experiments. And this cover lets us beam a narrow ray of light from the bulb. If I aim the beam at the plastic block at an angle and turn the other lights in the room off, you can see the light beam is bent as it enters the plastic, and again as it exits. This happens just like the car reaching the sand. The speed of the light ray decreases as it reaches the plastic block, but then speeds up again as it exits the block. This bending of light is known as refraction. We can say that the light is refracted. Here you can see the normal drawn at a right angle to the surface of the plastic block. And when we talk about angles of reflection and refraction, we describe them relative to this line. Here, the ray, known as the incident ray, reaches the plastic block at 45 degrees from the normal. This is the angle of incidence. The ray within the block, known as the refracted ray, moves through the plastic block at 30 degrees from the normal. This is called the angle of refraction. Well, light reflected off the pencil moves away from the pencil through water, and it's refracted as it travels between water and air. It speeds up when exiting the water, bending away from the normal before reaching your eyes. Your brain assumes that light travels in straight lines, so it looks like the pencil has been bent to reach the point where you think the light beam has come from. It's because of refraction that we're able to focus on things using lenses. As a light ray reaches this lens, the ray is refracted toward the normal. Then, when leaving the lens, it is refracted away from the normal. Because of the shape of the lens, all of the emergent rays are refracted towards each other, focusing at a single point called the focal point. This is called a convex lens, sometimes known as a converging lens, because the light rays converge as a result of going through the lens. It's this type of lens that we have in our eyes that allow us to focus light from objects onto our retina, so we can see a clear image.
Okay, great. Now, what did you understand from the video? Can we call our little scientist Sumaiyah to give her reflection about the video?
Sure, teacher. Light travel at different speed in different material. It slows down when moving from air to water or plastic.
Oh, excellent. Yes, that's because light bends when its speed changes. What else did you learn?
Teacher, I would like to share something.
Yes, please, Scientist Tasha. The floor is yours.
I learned that refraction through a convex lens helps focus light to form images. which is how we see things clearly.
Oh, very good. You captured the main concept well. Now let's move on to our hands-on experiment with teacher Sumaiyah.
Thank you, Teacher Humaira. Now, students, let's perform some experiment to understand reflection better. Please form two groups. Group 1, you will need a straw, glass of water, and your experiment worksheet. Observe the formation of light properties when the straw dips into the glass of water. Group 2, you will need a magnifying glass, an object, and experiment worksheet. Observe the formation of light properties when use magnifying glass to see object. Please perform the experiment as procedure in the worksheet. Record your experiment, complete your hypothesis, observation, and answer the question in your worksheet. I give 10 minutes to complete the task and submit the experiment video with the experiment worksheet to me. Now, I want to invite group 1 in front of class to present your observation and tell your friend the answer of question in your worksheet. Let's watch the experiment video from group 1. Friend, let's start the experiment.
What materials we need for the experiment today?
We need straw and glass of water.
First, take the straw and put inside the glass of water.
It is true. The image of straw look blended in the water.
Yes, this is because of the change of speed of incident rays and refracted rays from air to water medium.
The light properties we call as reflection of light.
Teacher, what are the other phenomenon that caused by refraction of light?
The other phenomenon that caused by reflection of light is twinkling star on sky at night. The starlight reflected by different air densities. The speed of starlight slightly changed in the path it passed through the atmosphere layer and made the appear of twinkles.
Another phenomenon is mirage on hot days that caused by illusion of water on road or in the desert. This because of refraction of light.
Great! Well,
Good morning, friends. I am representative from Group 1. Alright, everyone, let's look at our experiment worksheet about reflection of light. Our hypothesis says that when light travels from one medium to another, the speed changes and the light rays will bend. From our observation, we saw that the straw in the glass of water looked bent even though it's straight. This happened because light is refracted. It bends as it moves from air to water. In the diagram, we can see the incident ray and the refracted ray, showing how light changes direction at the water surface. The application of this property can be found in microscope and telescope, where lens use refraction to form clearer and magnified image. So this experiment proved that refraction occurs when light passes between different mediums and changes its direction. Thank you.
thank you, Group 1. You have done a perfect job. Now, I want to invite Group 2 in front of class for presentation. Please present your observation and tell your friend the answer of question in your worksheet. Let's watch the experiment video for Group 2.
Today we will perform the experiment of refraction of light.
The material we need are magnifying glass and object.
We use the magnifying of glass to see the object.
The image of object look large when we see through the magnifying glass.
Yes, this because of the change of speed of incident rays and refracted rays from air to solid medium. This we call as refraction of light.
Teacher, the microscope device also use refraction of light to magnify the virus and bacteria in the analysis sample, right?
Yes, you are right. The microbiologists always use it to see the small objects in their samples.
You are
Hello friends, I am from Group 2. So, from this experiment, the hypothesis is that light travels from one medium to another medium because of the change of speed and light rays will bend. We can observe here that the light refracted from air to magnifying glass causes the image to appear larger. This shows that light is refracted. This principle of reflection of light is applied in properties such as camera lenses and also contact lenses. Thank you.
Well done, both group. You clearly understood how refraction works. Now, I will hand over to Teacher Tasha for our quiz and reflection session.
Thank you, Teacher Sumaiyah. Now, let's have a short Q&A session. Do you have any question regarding this topic, class?
Teacher, I have a question. Why do the colors of a rainbow spread out like that?
That's a very good question. It is because each color has a different frequency and it bends at a slightly different angle. The color violet has the highest frequency and refracted the least, while red color has the lowest frequency and therefore refracted the most. Each color is refracted differently. The light rays bend at a different angle, resulting in a fanning out and separation of white light into the colors of the spectrum. Do you understand?
Yeah, I understand. Thank you, teacher.
Teacher, this is great. You make this question easy to understand.
Well, I'm glad. So, do you have any other questions or you want to share something with your friends?
Teacher, I want to share the other phenomenon is atmospheric refraction. I have explored the effect of this phenomenon. The phenomenon causes the advanced sunrise and delayed sunset. Due to the refraction, the sun apparent position is higher than its actual position. We see the sun about 2 minutes before it actually crosses the horizon. Similarly, during the delayed sunset, the sun remains visible as physically goes below the horizon because the refracted light continue to reach our eyes.
Great. That is such good sharing, Sumaiyah. So, anyone else who would like to share anything?
No, teacher.
No, teacher.
No, teacher.
Okay. Well, then, if you don't have any question, I think it is time for our quiz session. We shall start with Sumaiyah. Can you please give me the definition of refraction of light?
Yes, teacher. I think the answer is C. Refraction of light in the change in direction of light as it passes from one medium to another medium due to the change of its speed.
Are you sure the answer is C?
Yes, I'm sure, teacher.
Alright, let us look at the answer. Well, that is right, Sumaiyah. Very good. Now, I have a question for Humaira. Alright, which of the following phenomena is a result of refraction of light?
I think the answer is also C, formation of rainbow. Is it correct, teacher?
Alright, let's look at it. Yes, excellent. That is the right answer. Good job, Humaira. Lastly, Ain. Which instrument shows the application of refraction of light to form a magnified image of an object?
This is easy, teacher. The answer is D. All the above is correct.
I love the confidence, Ain. Now let's look at the answer. That is correct. The answer is D, all of the above. Microscope, telescope, and magnifying glass all uses the same principle of light, that is refraction. Good job, Ain. I'm so happy to see that you understand this topic very well. I guess it's almost the end of our class. So today, We can learn that refraction of light occurs when light passes from one medium to another, causing a change of speed and direction. Refraction explains many everyday phenomena and is used in lenses, eyeglasses, cameras, and even optical instruments. Depending on the medium, the amount of bending depends on the optical density of the two mediums. I hope you guys enjoyed today's lesson and please do explore more for our next topic using textbook and e-learning platform. Thank you class. See you again.
Thank you, teacher.
Thank you,
Bye.
teacher.
See you again.
Dah.